Say hello to the universe. It's inconceivably vast and mostly unknown, but ever since humans first looked up at the stars, we've been fascinated by the majesty and mystery of it. From the earliest priests and shamans to modern astronomers, we as a species have sought to lift the veil and unlock the secrets of this place. But while we have made great scientific progress, there remains so much we don't yet understand. And that's where dark energy comes in. This is Unveiled, and today we're answering the extraordinary question, how will NASA's new telescope solve dark energy?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
The problem at the heart of today's video is that when it comes to dark energy, we're only just beginning to learn the rules. Up until the year 1998, general consensus was that our universe is expanding, but that expansion should be slowing down. Whether it continued forever or stopped and collapsed, gravity would surely slow it up over time. Enter the Hubble Space Telescope, however. In 1998, while observing distant supernovae, data from Hubble showed that the universe is actually accelerating in its expansion. It's getting bigger at an ever-increasing rate. This was completely unexpected, and frankly, it threw the scientific community for a loop. No one knew how to explain it, and we still don't. But we did give the thing causing it a name: dark energy. We know dark energy exists then because of the effect it has on the universe's expansion. And we know it exists in vast quantities, making up an estimated 68% of the universe total. But that's about all we know. We have no idea if dark energy will continue to accelerate the expansion of our universe, for example, nor whether it could one day cause the end of the universe via an all-encompassing doomsday scenario affectionately known as the Big Rip. But in science, nothing is impossible. And NASA hopes to solve the mystery of dark energy with one particular piece of next-generation tech, the Nancy Grace Roman Space Telescope. Set to launch in 2025, it's named after Nancy Grace Roman, who was NASA's first chief astronomer and the driving force behind the Hubble telescope mission. Often called the mother of Hubble, it was Roman who lobbied NASA and Congress, pushing them to develop the telescope and convincing them of the importance it would have to the scientific community and the world. And history shows us just how right she was. It's only fitting then that the successor to Hubble will be named after her. But what will the Nancy Grace Roman Space Telescope do? At the top of its agenda is to investigate the key mysteries of the universe, including exoplanets and dark energy. Contemporary scientists now know that without an understanding of dark energy, we cannot ever hope to accurately understand how the universe began and where it may evolve to in the future. So according to NASA, the Roman will address two fundamental questions about dark energy: whether or not it is the driving force for expansion, and if it is, then how much has it or hasn't it changed over time? By peering back to the earliest formations in the universe, the Roman telescope will measure the presence of dark energy from almost the beginning, tracking how its distribution throughout the galaxy has developed, including how its prevalence may have perhaps risen and fallen. And it's this that will revolutionize astronomy and greatly improve our knowledge for the future. In addition to studying dark energy, Roman will also search for exoplanets. The telescope's primary mirror is 2.4 meters in diameter, about the same as Hubble's. However, Roman is equipped with a wide field instrument that has a field view of 100 times greater than Hubble's, which will again give astronomers an unprecedented view of the galaxy. Briefly put, when planets in other solar systems pass in front of stars, the gravity of those planets can make them seem brighter, and the wide field instrument will look for these microlensing events, clocking more of them than ever before to reveal what scientists hope and estimate will be another 2,600 exoplanets at least. And what's more, Roman is also equipped with a special coronagraph instrument. This will allow the telescope to manage the light coming from an exoplanet's nearby star, providing a far clearer glimpse of the planet itself, which is essential in figuring out whether or not it is, was, or could be hospitable. The wide field instrument on the telescope will also provide us with the largest, highest resolution images of the universe to date. Until now, we've relied on the Hubble for most of our best shots, but the Roman will take the baton. It will measure and capture the structure of our galaxy even more accurately, study the birthplace of stars, and even search for signs of former galaxies that have been destroyed over time. Individual asteroids, comets, and dwarf planets within the solar system will all be within its sights too, giving us a greater picture of space than ever before. With dark energy specifically, though, one of the things Roman will do is conduct a redshift galactic survey. This will look at how galaxies are distributed across the universe, which in turn will show how dark energy has evolved over the eons. Because the universe is expanding, objects move faster the further away we look, which causes the object's light to shift more towards the red end of the spectrum, which is information astronomers can use to reveal how fast any given galaxy is traveling away from us. And so, by mapping out the distances and positions of millions of galaxies, Roman will help us understand the evolution of dark energy. Another way of measuring dark energy, however, is via exploding stars, and Roman will do this too. It will be able to see thousands of supernovae throughout space and time, although it'll primarily focus on what are known as Type 1a supernovae, which come from binary systems containing a white dwarf. While typical supernovae occur in our galaxy about once every 50 years, Type 1As are far rarer, happening once every 500 years or so in the Milky Way. The explosions within them emit a bright, consistent amount of light, though, making it relatively easy for astronomers to calculate their distances, and therefore, crucially, to calculate how fast they're moving away from us, again enabling us to indirectly observe dark energy. Finally, Roman will also look at baryon acoustic oscillations, or BAOs, which are sound waves originating from the infancy of the universe, from its very earliest stages. In the first 500,000 years, the universe was comprised of primordial plasma, a dense hot liquid which underwent tiny changes in its density, which created sound waves that rippled out into the cosmos. Today, these sound waves have long died down, but they have effectively been frozen in place, and so have left an imprint across space. An imprint we can use, because as the universe has expanded, the frozen ripples have been stretched out. Roman will measure this stretching and how it has changed over time, for yet more insight into how dark energy has developed and shaped everything. Astronomers will combine all three of these methods: the redshift galactic survey, the Type 1a supernovae study, and the focus on BAOs in their quest to understand dark energy. But the sheer amount of data that the Roman telescope will collect could become overwhelming for them, with it being predicted that just one image from it could contain millions of galaxies. When the Roman is up and running, then, we'll likely need machine learning, a form of artificial intelligence, to help us process the gigantic amount of data it'll generate. At which point, we'll truly have stepped up our pace in terms of space exploration and gathering knowledge. We really could be on the verge of a new age of scientific enlightenment, and this telescope really could put us there. It's not hard to see why, then, the scientific community is so excited for the Nancy Grace Roman Space Telescope. With its launch, humanity is poised to make a great leap forward in its understanding of the universe, particularly with regard to one of the modern world's most important mysteries. And that's how NASA's new space telescope will solve dark energy.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.